All right, today we're going to talk about something called DMAIC. Now, this is a super powerful, structured way to solve those really tricky problems, the ones that just keep coming back. We're going to break down how it works and how it makes sure solutions actually stick. So let's jump right in.
So let me ask you something. Does this sound familiar? You spend all this time and energy fixing a problem at work, you think it's done, and then boom, a week later, it's back. It's this endless, frustrating cycle, right? You're just constantly firefighting, and it's exhausting. But here's the thing. What if there was a better way? A way to put those fires out for good?
And this really shows you the difference. Over on the left, you've got what most of us do, the old way. It's kind of chaotic, right? It's all about guessing, using assumptions, and slapping on quick fixes that only deal with the symptoms. But then, look at the right side. That's the DMAIC way. It's a clear, straight path to a real solution because it's built on data and evidence. It's all about getting to the root of the problem.
So what is this DMAIC thing anyway? Well, at its heart, it's a structured, data-driven problem-solving method. It comes from the world of Lean Six Sigma. And the whole point is to solve problems the right way so the fix actually lasts. The acronym itself is pretty simple. It just stands for the 5 phases: define, measure, analyze, improve, and control.
And there they are. Think of this as our roadmap for the next few minutes. We're going to walk through each of these 5 steps one by one, and you'll see exactly how they connect to build a rock-solid, lasting solution. Okay, first up, the define phase. This is step 1, and it's so important. Before you jump in and start trying to fix things, you have to get absolutely crystal clear on what the problem is. And just as crucial, you need to understand why it even matters. Why does this problem need to be solved for the business or for your customers? And this quote right here says it all, doesn't it? A poorly defined problem leads to a wrong solution. I mean, think about that. If you get this first step wrong, everything else you do, all that hard work, could be completely wasted on solving the wrong thing. That's why clarity, right here, is everything. So how do you get that clarity? Well, you use some specific tools. For example, a project charter. Think of it like a contract for the project. It lays out the goals and what's in and out of scope. Then there's something called a SIPOC diagram. It's just a fancy acronym that helps you get a high-level, bird's-eye view of your whole process. And of course, you have to listen to the voice of the customer to really understand what's important to them. When you put all these pieces together, you build this incredibly solid foundation for everything that comes next.
All right, so we've defined our problem. Now what? Now we move into the measure phase. This is where the guesswork stops and the real fact-finding begins. We need to understand just how big this problem really is.
And here's the mantra for this phase. You cannot improve what you do not measure. It's just common sense, right? How will you know if you've actually made things better if you don't know where you started? So this phase is all about creating that factual starting point, that baseline.
So how do we do it? Well, we use tools like process maps to literally draw out the workflow. We create a really solid plan for how we're going to collect data, and then we establish those key baseline metrics. You can think of it like taking a really honest photograph of your process right now, warts and all.
Okay, we've defined the problem, we've measured it. Now comes the fun part, the detective work. This is the analyze phase. We take all that data we just collected and we start digging. We're looking past the obvious symptoms to find out what's really causing the problem.
And the most important rule in this phase? Leave your opinions at the door. Seriously, we're not guessing anymore. We look at all the potential causes, sure, but we let the data be our guide. The data, and only the data, is going to point us to the real culprit.
The main thing we're doing here is called root cause analysis. It's really just a systematic way of thinking that stops us from putting a Band-Aid on a symptom and instead forces us to dig deeper and deeper.
And you know what? One of the simplest but most powerful tools for this is called the 5 whys. It's pretty much exactly what it sounds like. You just keep asking why over and over again like a curious kid until you get past the surface level answers and find the real issue.
Let's look at a super simple example. Problem: the machine stopped. Okay, why? Because the fuse blew. Now we could just replace the fuse, but that's just fixing a symptom, right? So we ask again, why did the fuse blow? Because the circuit was overloaded. See how that works? We're already one level deeper, closer to a problem we can actually solve. You just keep asking why until you hit a dead end.
Now, the 5 whys is great, but it's not the only tool in the toolbox. For more complex stuff, you might pull out a fishbone diagram to brainstorm every possible cause you can think of. Or maybe a Pareto chart. That's the one that helps you find the vital few causes that are creating most of your problems. And for the really tricky ones, you might even get into statistical stuff like hypothesis testing to prove, with data, that A is definitely causing B.
So we've found it. We've identified the root cause. Now, finally, we can start talking about solutions. We're moving into the improve phase. This is where we come up with ideas, test them out, and implement fixes that are designed to get rid of the problem for good.
So a big part of this phase is brainstorming solutions. But, and this is so important, you don't just roll out a big change everywhere. You pilot test it. You try it on a small scale first to make sure it works and doesn't cause any new problems. This is also where you might use a really cool technique called poka-yoke. It's a Japanese term that means mistake-proofing. The best example is a USB cable. You can only plug in one way, right? The design makes it impossible to make a mistake. That's poka-yoke.
Okay, so we've fixed the problem. We should celebrate, right? Well, yes, but we're not quite done. This brings us to the final, and you could argue, the most important phase, control. This is all about making sure that all of our hard work, all those improvements, actually stick around.
And this is why it's so critical. Because what happens if you don't have a plan to keep the new process in place? Well, people and processes tend to drift back to the old, comfortable way of doing things, even if it was the wrong way. The control phase is basically the lock on the door that keeps the improvements in and the old problems out.
So what does that look like? Well, you'll update your standard operating procedures so everyone knows the new way to work. You might use things like control charts to keep an eye on performance over time to make sure it's not slipping. And you'll put together a formal control plan that spells out exactly how you're going to maintain these gains.
Okay, as we start to wrap this up, I want you to remember one key thing. DMAIC is more than just a 5-step checklist you follow. It's really a totally different way of thinking about problems.
And that's really the big idea here. It's not just a method, it's a mindset. It's a disciplined approach that teaches you to value hard evidence and data way more than just gut feelings or what someone thinks is happening.
And when that mindset starts to spread through a team or a whole company, the benefits are just massive. You learn how to think in a more structured way. You create solutions that actually last. And the best part? You stop spending all your time firefighting, which means things become way more stable and predictable. So I'll leave you with a question to think about. What's that one recurring problem, that one fire you're always fighting at work that you could maybe finally solve for good if you just replaced your assumptions with some facts? Something to think about. Thanks for joining me.